Welcome students. This is our class for topic calculus of variation. Related subject is important both in academic and competition way. Before understanding what is meaning of calculus of variation, we are going to discuss two problems. The first problem is problem of shortest path between 2 points, and second is problem of shortest time. Let us discuss these problems one by one. What is the first problem? In this problem, we have 2 points A and B having coordinate points x1 and y1 and x2 and y2 respectively. See, we can draw many curves joining these points. So, our basic objective is to find that curve along which length will shortest. This means I have to find that curve joining A and B having minimum length. This is our problem. I have considered x-axis, y-axis. Consider a small element of curve y, PQ, having length ds. In a magnified view, I have made here. This is our magnified view. Since ds is a small element, so it can be considered as a straight line, and it will be dx and it will be dy. On applying Pythagoras theorem, I can write this. ds equal to under root dx square plus dy square. So length of element PQ can be given by this. Taking dx as a common, I can write it like this. Now I have calculated length of this small element. Now by integral calculus, the length of whole curve A to B can be calculated by integrating this in this limit A to B. So length of a joining curve will given by integration A to B this. Here in place of dy upon dx, I have written y dash. So here this is a function, and this is a function and of y, so which is a curve, and I have written it fy. Now fy represents the length of a curve y joining A to B. Now understand what I have to do. In this problem, I have to search a curve y for which the length fy is minimum. This means I have to minimize the Fy. This is our problem, and you know that its answer is straight line. We will discuss this later, how its answer is coming and how we will process it. Consider the second problem. Second problem is problem of quickest descent. This means I have a point O and I have a point A here. I have 2 points and there is a free fall. One bead is moving from here to here. See, if this particle moves along this curve under the influence of gravity only, this means no another force is working, only gravitational force is working. So if a bead starts moving along this curve, it will have different time, and if this bead starts moving along dotted curve, it will have different time. This means time taken by bead in moving O to point A. In moving point O to A will depend upon the curve. So, our basic objective of this problem is that I have to find that curve moving along which the time will minimum. This means I have to minimize the time. I have to search that curve along which time will minimum. This is our second problem. See, this problem is also known by name Bhasker-Chandra problem. A Bhasker-Chandra problem has a very importance in calculus of variation. This problem was studied by John Bernoulli. It is one of beginning problems of this study. Let us discuss this problem. See, for convenience, I have taken y-axis downward side and x-axis towards this side. This is the starting point of the bead, and where it has zero velocity, and this bead has a free fall and it has to move to point A. The basic problem is that I have to find out that curve moving along which will time taken will minimum. This means time should be minimum. For discussion of problem, I have considered a small element of this curve PQ and let its length is ds, and I have taken here velocity v of a bead and here coordinate x and y. If its coordinate is x, y and y, what it means? From here to here it will be x, and here to here it will be y. It will be x and it will be y. See, x, y. This is coordinate of P. Now, first I will calculate time taken by speed to cover PQ. You know that the formula of time is distance upon velocity. So distance is here ds and velocity is v. So time taken by bead in covering PQ will ds upon v, and ds can be substituted by this under root dx square plus dy square as we have done in previous problem, and I have taken dx as a common. In place of dy upon dx I can take y dash. See here, this is time taken by bead in covering distance PQ. Now time taken by bead in covering distance PA along curve y will this integration of this from 0 to A. This is equation 1. Now one thing is that at starting point, as you know that there are two types of energy, kinetic energy and potential energy. At this point the particle has only potential energy, its kinetic energy is 0. While as it is moving down, this potential energy is converting into kinetic energy, and at this point this. So while moving along O to A, there is loss in potential energy, and this loss of potential energy is converted into kinetic energy. So I can write that loss in potential will equal to kinetic energy at point P. So loss will be equal to mg multiply the height of descent. See the height of descent is how much it has gone down, y, by y it has gone down. So loss in potential energy will mg y, and it will equal to half mv square, and the gained kinetic energy. And from this I can calculate v. This. So I have here I have made velocity as a function of y. So I can substitute this value of v here, and I get this. This is the function, and this function represents time. This function represents time taken by particle in moving along OA. This. So what is our basic problem? Our basic problem is here that I have to find that curve for which value of ty will minimum. This means time will minimum because it is representing time. See, so I can write here. So in second problem, what we have to do to find such y, this means I have to find such curve joining OA which make time ty minimum. This is our Bhasker-Chandra problem, and answer of this problem is cycloid. These two problems are very important in calculus of variation. These problems gives us idea about an important topic of functional. Now what is the functional? See here, generally in a function generally there is a domain and there is a codomain. In domain there may be anything. There may be real numbers, there may be complex numbers, there may be integers, etc., etc. But here we see that if we consider this function, see, this is function of y. This is function of y here in first problem. It is function of y, and this is function of y. And what y is? Y is a curve here. And what is a curve? Curve is a function. So what it is? It is function of a function. This means in this domain there are curves. See, and so this is function of a function. And what we are doing it? What f is doing it? F is finding the length of this curve. F is a correspondence from A set to B. Here A is a domain, and domain contains what? Curves. Curves joining A to B point in first problem. This means curves. This means A contains functions. And B is here real number, and image is here length, because it is representing length. This means fy is a special type of function. What it is? It is function of curves, or in other words, it is function of functions. So that special type of functions are known as functionals. So I can write it. A functional is a function of functions. Or in other words, I can say that a functional is a function having domains as a set of functions. See here, the domain of this function is set of curves, and curves are what? They are functions only. So this is functional. Similarly, we can explain the second problem. What is the second problem? In second problem, T is a correspondence between set of curves to real numbers. Here, what Ty is representing? Ty is representing here time. This is the time here. And here, this is a set of curves. Set of curves joining O to A point. This means this domain is containing many curves, or in other words, this domain is containing many functions. So I have T as a function having domain as a function, as a set of functions. So T is also function of functions. Hence T can be said to be a functional. Now I think that concept of functional is clear now. And concept of functional is very important. Let us move further. We have a comparison between calculus of function and calculus of functionals. So here I have done a comparative study. See, calculus of function, this means as the calculus which you are reading in class 11, 12, like this, we have a function. And in calculus of variation, we will have functional this. In calculus of function, you study how to find out differentiation of function and integration of function. And in calculus of functional, you find out integration of functional and differentiation of functional. In calculus of function, could you remember there were problems of maxima and minima of fx? Similarly, we have problems of maxima and minima of functionals, as in problem 1 and 2. What in problem 1 we are doing? We are trying to minimize the fx. What in second problem we are doing? We are trying to minimize the ty. So in calculus of functionals, we are trying to maximize or minimize the functional. These special type of problems are known as variational problems. These are variational problems. Variational problems are those problems in which we study maximization and minimization of functionals. And the basic point of today's lecture, that what is the meaning of calculus of variation. Calculus of variation means study of variational problems. This means in calculus of variation we will learn how to maximize or minimize the functional. That is. Thank you for watching the video.